And I shouldn't use the word combination because it comes up with something else in here, but it's just easier to say the word combination. But the fundamental accounting principle says if we have this many options of this, and this many options of this, and this many options of this, and I can choose one of each, how many total combinations or how many different outcomes do we have? And we'll get into that in a little bit. A permutation is an arrangement where order is important. And that's like selecting people for different jobs, like the FFA. There are different offices of the FFA. There's president, vice president, secretary, um, student advisor, treasurer, and I forget what else. But okay, there's different offices. So different people for different offices. Order is important. Where a combination, order isn't important. So that's like a city commission. People get elected to city commission, they all have equal weight. Not one person's president, vice president, something else. There's the mayor, he's elected separately, but the city commission, they're just members. Okay? So they all hold equal weight. Where the people have different jobs, that's a permutation. So like I said, we'll get into that. And n factorial is an n! An exclamation point, n. Yeah, okay. Now you're awake. So, n factorial means whatever number it is, like let's say it's 8 factorial. Then it's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Or if it's 3 factorial, it's just 3 times 2 times 1. Okay? So, if it's 3 factorial, it's not 3! It's just 3 times 2 times 1. Okay. All right. So, this first thing. Are you awake now? You have a headache, and I'm giving you a bigger headache. All right. So the first thing we're going to show you here, boom, is, okay, down in Jubashine, okay? They have that little lunch wagon or little hut out there. And let's say they have a $5 lunch special there, okay? They're not calling it the $5 lunch because then they'd be stealing BQs, registered trademark stuff there. But let's say they have a $5 lunch where you can choose either pizza, a hot dog, or a cheeseburger. One of these three. You can choose one of these two, Doritos or Lay's. And you can choose one of these four, pop, water, lemonade, or Gatorade. Okay? How many different options do you have out of there? Because you could get pizza, Doritos, and a pop, or you could get a cheeseburger, Lay's, and lemonade, or you could get a hot dog, Doritos, and Gatorade. Or how many different ways can I go there? 24 different ways. Calvin Martin got it. Because this is the fundamental accounting principle. You get one choice out of these three. So that's 3. You get one choice out of these 2. That's 2. 3 times 2 is 6. And you get one choice out of these 4. That's 4. So 3 times 2 is 6 times 4 is 24. There's 24 different ways we can do that. Okay? That's the fundamental accounting principle. When we go through the problems, you got to be able to look at the situation and say, well, is that the fundamental accounting principle? Or is that this? Or is that this? Okay? So you'll have to look at that a little closer. All right. FFA has 3 offices. Let's say 10 people in here were running for the offices. And instead of going through the interview process and all that, they just pull your name out of a hat. Okay? So they pull your name out of a hat and they say, well, the president will be, and they pull a name out. The vice president will be, and they pull a name out. How many different ways are there that you could do that? Well, we had 10 people. Okay? So let's say we have 10 people. Okay? So, you have person A, B, C, D, E, F, G, H, I, J. 1, 2, 3. There's 10 people. Okay? All right. So A could be president, D could be vice president, and H could be secretary. Or A could be president, J could be vice president, or E could be secretary. And if I wrote all these out, it would take me a long time to figure out all the different ways I could do that. So there's an easier way of doing it called a permutation. Okay? A permutation is this. You take the possible number of people, permutation, the actual number of offices, or the actual order of things, the ordering of things. So, n is the first number, so you go 10 factorial over 10 minus 3 factorial. 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Woofda! That's a lot of pressing buttons on your calculator, isn't it? And then 10 minus 3 is 7. So 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. Well, guess what? This is all multiplication. So in multiplication, you can cancel, right? You can cancel those and those and those and those and those and those and those. So what is it really? It's just 10 times 9 times 8. Well, 9 times 8 is 72 times 10 is 720. So yeah, it would have taken me a long time to figure out all the different combinations of this, all the different permutations of this. 720 different ways those people, if they were drawn out of a hat, could have an office. Okay?
But wouldn't that be assuming that one person could have all three places of the office at the same time?
No, that is not. Nope, this separates them out. Okay? All right. So get your calculators out because I want you to help do this a little bit. City council. City council is a combination. Okay? Because people don't have specific offices, they're just a council member. So this is a combination. So we're going to do 10C3 for combination. What's a combination? Well, it's the first number factorial over the last number factorial times the first number minus last number factorial. So it's 10 factorial over 3 factorial, 7 factorial. All right, let's write out 10 factorial again. 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 7 times 6 times 5 times 4 times 3 times 2 times 1 times 1. Can I do any canceling? The 1s, the 2s, the 3s, the 4s, the 5s, the 6s, the 7s. So it's 10 times 9 times 8 over 3 times 2 times 1. Well, that's 720. This is 6. 720 divided by 6 is 120. Okay? All right. So this is doable, right? We can do this. Now, the hardest thing for you guys will be to do is to recognize exactly which problems are which. So let's go to the second page of this. 9 factorial. How would you do that? What would you do on your calculator? 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay? If there was only a button that could do it for us on our calculator. But I don't know if any of you know where a button like that would be on your calculator. There's a button, Mr. Kennington? Oh, you click the PRB button. If you don't have your calculator out right now, you better get it out. All right. So you go 9, push the PRB button, find the exclamation point, and press the equals button. What do you get?
362,880.
Okay, so what does that help by using those buttons prevent? Carpal tunnel, great response. I wasn't thinking that. I was thinking as when you go 9 times 8 times 7, you could miss a number. You could accidentally hit a number twice because you're typing so many of those in. So yeah, we do have a workaround for doing that. If there was only a P button on your calculator, if there was only a P button on your calculator. All right, you were going back to that PRB button. So 7 permutation 3 would be 7. Hit the PRB button. Hit the NPR button, or whatever it is. I don't know how it's labeled in your calculator. Hit the 3 button and hit the equal button. 7 permutation 3. Let me do this in my head. It'd be 20 times 42, 840, right? 20 times 40, 20 times 40, okay. It'd be, oh, no, it'd be 7 times 6 times 5, and then the rest would cancel out. So 42 times 5 is 42 times 5. 210?
Yeah.
Dang it. I'm not so smart after all. All right. 9C4. How would you, yeah, you should know how to figure that one out now. What's 9C4? 126. Okay, now we get into word problems. For a segment of a show, a disc jockey plays 5 records. 9 records. There are 9 records to select from. And how many different ways can the program for this segment be arranged? Now, order is important for playing records on the radio. Okay? Because if you play one first, that's different than playing one, that same one third. Okay? So they want you to use a permutation for this. So what will we put into our calculator? What's the first number we'd enter? 9. So it'd be 9P5. So it's 9 PRB NPR 5 equals. What do you get? 15,120 with different ways of putting that segment together. Okay, this next one is not a not a permutation or a combination. Let's think about it. Okay, you've seen on the garage doors, people have codes they punch in to get into have their garage doors go up. This is a little more complicated, but in the same concept. Okay, you can choose 3 letters and 5 numbers for your entry code. Now, how many letters are there to choose from in the alphabet? And they don't say that you can't repeat the same letter, so you could go A, and then 1, 1, 2, 3, 3, or something like that if you want to. So you got 26 combinations for each. And for these, how many single digit numbers are there? 9 or 10? 10, because you have the number 0 as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. So there are any different ways. What do you think you do on your calculator with this? It's kind of like the lunch stand problem. Because there's 26 ways and then 26 more ways and then 26 more ways. You just multiply them all together. And it's a huge number. How big is our huge number? I think it's bigger than 17,000, isn't it? Or is it 17,000? 1,000,000, yeah. 1,757,000. 175.
1,757,600,000.
Okay, now, why would you ever want to know that there's 1,757,600,000 combinations to a entry code, a security device like this? In case you're a crooked and you want to break in, you know there's 1,757,000. It's not worth your time. Oh, okay, yeah. Okay, what's another better way of saying, but kind of what you're saying, but a better way of saying it? Who would be trying to put out that there are 1,757,000,000 combinations to this, so it's super secure? Or the people marketing this little entry code thing, right? They'd say, hey, this thing is so secure that once you put in this, there's a 1,757,600,000 chance that somebody's going to guess the entry code. That's that secure. Yeah, unless somebody puts on a simple entry code like that. Like your phone. Okay? Your phones. Let's do this one right now. We're going to diverge. There's 10 digits on your phone. If you have a 4-digit passcode, how many different passcodes could you put in?
Yeah, 10,000.
10,000. So then Apple went away from the 4-digit passcode and they went with a 6-digit passcode, which it inflates that number to 1,000,000. So when you're trying to guess somebody's passcode, if you don't have any information and just trying at random luck, if they only have a 4-digit passcode, you got a 1 in 10,000 chance. You got a chance to get in there. But when they go to a 6-digit passcode, that's 1 in 1,000,000 if you're going to guess it at blind luck. Thank you. You got 1 in 1,000,000 chance. And that's why they went to the 6-digit passcode, because it's tougher to guess. Okay. Baby Diane wants to arrange 5 blocks in a row. How many different arrangements can she make? So there are 5 blocks. Once she places, she's got possibility of putting 5 different blocks there. Once that block is placed, how many different blocks does she have for the second one? 4. How many for the third one? 3. Then, what is 5, 4, 3, 2, 1? What is that? That's a factorial, right? Multiply them. What's 5 times 4 times 3 times 2 times 1? She's got 120 different ways of placing those blocks. Okay? All right. Picking books off a shelf, selecting 3 at random. How many different books could you select? Does the order matter? No, you're just going to read a book. It doesn't matter the order. Now, if you select a book in a series out of all these different series like Harry Potter, does it matter if you read the first book before the second book? Yes. It matters if you're reading a series, but just grabbing books at random doesn't matter. If it doesn't matter, combination or permutation. Combination, order doesn't matter. City Commission, I think you can do that one, okay? Because it's 8C3, you can do that. Lottery. What's the probability of winning the lottery if there's, if you've seen those ping pong balls in the lottery machines and they spit them out and there's 7 numbers, and the numbers don't repeat. So there's 61 numbers as they spit them out. What's the probability of having the winning ticket if you just get a ticket at random? Okay, the first number, there's a 1 in 61 chance of having the right number. Once that number is down, you don't repeat that number. That one's been taken out. The numbers don't repeat. So the second one is a 1 in 60 chance that your number will be correct. So actually, it's a combination, right? Because the order isn't important. You can have the 2 ball come out first or the 21 ball come out first. It doesn't matter. They just count the balls. So it would be 61 combination 7, which is a big number. And they want probability. So it's 1 out of that many. What's 61 combination 7? It's a pretty big number on the bottom.
436,270,780.
Something like that. One out of 436,270, or 436,270,780. All right. This chocolate, we've already seen that. Floral arrangement, combination, because order is important. Okay. Math Excel for school today is down for the count. So we can't do Math Excel for school. Aww. So, if we can't do Math Excel on computer, what are we going to do? Math Excel on paper.